Dear students, in this class we are going to prove that root 3 is a rational number. So the problem will start with this, that we are going to assume that root 3 is not irrational, it is rational. So you can write as the first step, let us assume that, let us assume that, let us assume that root 3 is a rational number. It is a rational number. Okay, when you consider it as a rational number, then you can write rational number in the form of a by b, right? A by b. So rational number, it is a by b, where a and b are co-primes, where a and b are co-primes. You know what are co-primes? Co-primes are the numbers whose HCF is 1. The hash common factors of the co-prime number is 1. Okay. Now here what you're going to do, you're going to square this on both the sides. Square this equation on both the sides. So square on both sides. On both sides. So when you square it on both the sides, it will be written as 3 square equals to a square by b square. Okay. So this is also equal to 3 equals to a square by b square. Okay. In this way, you can write as b square equals to a square by 3. Now you can see b square equals to a square by 3. From this equation, you can say that 3 divides a square. 3 divides a square. If 3 divides a square, you know that 3 also divides a. Then 3 also divides a. Okay. Now name it as equation 1. Okay. If 3 also divides a, then from this you came to know that 3 is a factor of a. 3 is a factor of a. Hence 3 is a factor of a. 3 is a factor of a. Okay. If 3 is a factor of a, then a is a multiple of 3. So you can write a equals to 3 times c. Okay. A is a multiple of 3. Now to this equation you have to square again on both the sides. When you square again it on both the sides, it will be a square equals to 3c whole square. Okay. And you know that a square's value already from this equation 1, you can write a square equals to 3b square. So from this equation you can write a square is equal to 3b square. So 3b square equals to 3c whole square. Okay. Now from this equation you can see that 3b square equals to 3c whole square means 9c square. It is 9c square. Okay. Now you can see here it will be 3 1s are 3, 3 3s are 9. So from here you can take it on as b square equals to 3c square. B square equals to 3c square. Okay. Now let me rub this portion so that you can see the other part properly. Okay, from this equation, you know b square equals to 3c square. So from here you can write b square by 3 is equal to c square. Now from here you see b square, 3 divides b square. So 3 is a factor of b. So you can write 3 divides b square, then 3 divides b also. Then 3 divides b also. 3 divides b also. In this way, 3 is a factor of b. 3 is a factor of b. Okay. Now here you see, here you got 3 is a factor of a, and here is you got 3 is a factor of b. From this two, 3 is a factor of a and 3 is a factor of b. What you can make out? You can make out that 3 is a factor of both a and b. You can make out that 3 is a factor of both a and b. 3 is a factor of both a and b. From equation 1 and 2, we can say that 3 is a factor of both a and b. 3 is a factor of both a and b. Okay. Now in the beginning we have considered A and B are co-prime numbers, but here we are going to get 3 is a common factor, or it's one more factor of A and B. It means for our assumption that rule A and B are co-prime factor is not correct. So here you can write this contradicts our assumption. This contradicts our assumption that A and B are co-primes. A and B are co-primes. A and B are co-primes. Okay, so this A and B are co-primes. So therefore, you can say root 3 is irrational number. Therefore, root 3 is irrational number. Hence proved. Hence proved. Hence